Hello. Today we're going to talk about 9.2 arithmetic sequences. So a sequence is just a pattern, okay, just a pattern of numbers. So for instance, in our given, what is the pattern? So I like to look at the first term compared to the second term. Well, you can see that we're adding 9 to it. And then if we go to the second to the third term, we also are adding 9 every single time. Okay, so you can see that continues for every term with each consecutive term. So add 9. That's called an arithmetic sequence. Okay, that's when you have the difference between any two numbers. So we are adding a number, a constant number each time. That's called the difference. Okay, yes, you can add a negative number. Okay, so it can be negative or positive. You're just adding a number each time. All right, there's actually a formula that you can use. So let's derive it. Okay, so here, to go from the first term to the second term, notice how I wrote it. It's t with the subscript of a 1. I like to do a sub 1 just because I don't like using t's. They look like plus signs. So you'll see me write these as a sub 1 or a sub 2. That means second term, first term. This is third term, fourth term, so forth. All right, to go from the first to the second, we're adding 9. Well, then to go from the second to the third, we're adding another 9. So really, we're adding 2 9s. Then to go from the third to the fourth, we need another 9. So we add 3 9s. So now let's notice what's happening, right? If, let's see. I'm going to use my highlighter. That might help. So if this is the first term, we'll notice we didn't add any 9s. And the second term, we added, 1 9. Okay, so the first term was plus 9 times 0. And then we had the second term was 9 times 1. The third term is 9 times 2, 4, and there's a 3. So hopefully you're noticing that if I were to do like the 13th term, I would just need to take 3 plus 9 times 12. The relationship here is it's 1 less than the term. So for the nth term, okay, so you say that as the nth term, you do 3 plus 9 times n minus 1, whatever that subscript was. Okay, you work this out. The 13th term would be 111. Okay, so this is our formula. Notice the 3 plus 9 times n minus 1. So the 3 represented the first term, or a sub 1. 9 represented the difference, so D for difference. And n is which term? Which term? So let's apply that general formula to a pattern. So here we have a pattern 4, 7, 10, etc. So the first term, the first term in the sequence is 4. And the difference we can get by taking one term and subtracting the term before it. So 7 minus 4, or 10 minus 7. Both of these give us 3. So the difference is 3. Now, to find the nth term, so we would have a sub n equals, the first term, which is 4, plus d, which is the difference, so plus 3, times n minus 1. There's your formula. Okay, it's very important that you understand that a sub n That's the actual term. And n is where it is in line. So which term? First term, third term, 100th term. Okay? Term. Now, to find the 20th term, all we would need to do is take that first term plus the difference times n, which is 20 minus 1. We plug that in, I believe we get 61. Yeah. Okay. Feel free to try these on your own if you got comfortable with the formula, but I'll walk you through it. So for the first problem here, we want to find the 100th term. So to get the 100th term, we take the first term, which is 17. We add the difference, which is 5. And we multiply by, well, n minus 1. Well, what's n? N is 100. So really, 17 plus 5 times 100 minus 1. We work that on our calculator, we should get 512. So that's the 100th term of the sequence. Much better than listing them all out. Yes, I've had students do that. Go for it, but usually when kids write out 100 terms, they usually make a mistake somewhere. Okay, they miscount. They give me the 98th term, or they added incorrectly one time and it just messed everything up. All right, number 2. Okay, so we want to understand our formula. That's what's really going to help us. So A7 equals A1 plus D times n minus 1. A1 is the first term. So 5 plus the difference, which they gave us, is 3. So now we need to figure out what n and A sub n is. 68 is a term. Okay? That's standing in line. That's not the 68th term. It is a term. So it doesn't represent n. That represents A sub n. We want to know which term, so we want to figure out what n is. So we got to work it out. All right, we do 68 plus 5, not plus 5, what am I doing? Equals 5 plus 3n minus 3. Let's see, so you get 66 equals 3n, 22 equals n. All right, so now for part 3, write an equation for the nth term of an arithmetic sequence. So the nth term, first term, plus the difference, times n minus 1. I'm fine with you writing that. If you want to simplify it and combine like terms, you'll end up with, 8n minus 5, either one. Okay, this is the more simplified, reduced form. Okay, so that's probably how I'm going to put it on the test. So I would just simplify it. Okay, when you have terms between any two non-consecutive terms, non-consecutive means not next to each other. Okay, so they're not touching. So that would be like 32 and 68. So the arithmetic means the numbers in between 32 and 68 would be 41, 50, and 59. Those are the arithmetic means. So let's do an example. We want to find two arithmetic means between 4 and 19. So I'm going to do 4, comma, some term, another term, and then 19. Now, remember, this is arithmetic, okay, which means we're adding something every time. So to go from this term to this term, I'm going to do 4 plus whatever the difference is. To go from the second term to the third term, I'm going to add another difference. So 4 plus D plus another D. Then to go from the third term to the fourth term, I need another 1. So that's going to be 4 plus 3d. So that means that last term I got 19 has to equal 4 plus 3d. You can also think of it as we had how many jumps? Well, okay, we had 1 jump, 2 jumps, 3 jumps. So we had 3 differences we had to add to that first term. Okay, so we solve that. We get 3d equals 15. So the difference is 5. So that's what you're adding every time. 4 plus 5 is 9. Plus another 5 is 14. Plus another 5 is 19. So your arithmetic means are 9 and 14. All right, let's find some more examples. Okay, try these on your own. We want 4, so we have 15, comma, 4 terms. Okay, I just like the visual. So we know to get to 50, you take 15, and we're going to add 1 jump, 2, 3, 4, 5 jumps. So 5 differences to get 50. So we get 5d equals 35. So the difference is 7. Oh, but that's not our answer. Don't do what I just did. Okay, add 7 to 15, right? Add your difference. So we get 22. Then we get 29. Then 36, 43, and then 50. So the answer, in order, would just be this. Those 4 terms. Oh, sorry. All right. Let's see. The next one, number 3, insert 3 arithmetic means between 18 and 54. So 1, 2, 3. So 18 plus, this is where I get kids messed up. They want to say 3 because there's 3 in between. It's not what we've been doing. There's 1, 2, 3, 4 jumps. Okay, so we get 4d equals 36. And our difference is 9, so we just keep adding. 27, 36, 45. So that checks out, because I started with that first number they gave me and I ended on the same number. If I didn't, then I did something wrong. Okay, hopefully this is making sense. If not, feel free to come see me in class and we'll go over some more. Oh, I forgot to mention, if you wanted to get the number before or after, you still do the same thing. The difference, we add 9 to go that direction. So if we're trying to go from 54 to 45, we would subtract. So to go to the left direction, oh, maybe it might help if I draw this the same way, we're going to subtract 9. So the term before 18 would have been 9, then 0, right, and so on. Okay? I hate how I drew that. I gotta fix it. It's gonna drive me crazy. Okay, close enough. All right.